Neupane. Today I am here to tell about rocks, mountains and geochronology. A rock or stone is a naturally occurring solid substance which is composed of one or more minerals. Granite is the example of rock which is composed of mainly three minerals. They are quartz, feldspar and biotite. The branch of science that deals with the study of rocks is called petrology or lithology. Now let's talk about types of rocks and types of rocks formation. Rock can be classified according to their chemical composition, permeability, texture and particle size. They are mainly classified into three types. They are igneous rocks, sedimentary rocks and metamorphic rocks. The word igneous is derived from the Latin word ignis, meaning fire. The rocks which are formed by the cooling and solidification of magma are lava are called igneous rocks. For example, granite, pumice, dianites, peridotite, syenites, etc. Formation of igneous rocks. The magma is the molten rock present deep inside the earth crust. The geologic cycle begins with magma. This melting of rock is caused by the increasing temperature, decreasing pressure, or change in composition. This magma cools down as it moves towards the surface, forming the igneous rocks. Types of igneous rocks. On the basis of texture, that is shape, size and arrangement of mineral grains in a rock or mode of occurrence, igneous rocks can be classified into two types. They are intrusive or plutonic rocks and extrusive or volcanic rocks. The rocks which are formed below the ground when the magma cools and crystallizes within the earth's surface is called igneous or plutonic rock, for example granite, whereas the rocks which are formed when the magma arrives on the ground in a molten state as lava during a volcanic eruption and cools down very rapidly are called extrusive or volcanic rocks, for example pumice or basalt. Sedimentary rocks. The rocks that contain the layer of sediments are called sedimentary rocks, for example limestone, sandstone, shale, clay, etc. Formation of sedimentary rocks. Fragments of earlier rocks, minerals, organisms, chemical precipitates, organic compound, etc. combine and deposit on the surface of the earth or within water bodies by the process of sedimentation. As a result, it forms sediments. As time passes, more and more layers are deposited and combined with the previous layer. The lower layer undergoes high pressure and due to the weight of upper layer and form a rock called sedimentary rock. Different sedimentary rock. Clay. It is formed from the decayed plants. It is mainly used in the power plants to generate electricity. Next one is limestone. It is mainly used in the manufacture of Portland cement, production of lime, manufacture of paper, glass, fiberglass, insecticides, and also coating as on many types of chewing gum. So it is well stratified in thin beds. It is a component. It can be a component of bricks and cement. Conglomerate. It consists of round or angular rocks or mineral fragments cemented by silica, lime, iron oxide, etc. It is used in construction industries. Sandstone. It is more or less round. It is principally used for construction. Now let's talk about metamorphic rocks. The rocks which are reformed from the pre-existing rocks like sedimentary rocks and igneous rocks due to the change in temperature and pressure are called metamorphic rocks. Formation of metamorphic rocks. When the condition of the pre-existing rocks like temperature and pressure are changed, the pre-existing rocks reasons into the other new form of rocks. This process is called metamorphism. During metamorphism, the original rock transform into the other form of rock by the process of recrystallization. These rocks have different physical and chemical properties. The temperature and pressure required for the metamorphism of a stone are actually very high than those found on the earth's surface. The temperature more than 200 degrees Celsius and the pressure of 1500 bars are the essential condition. Different types of metamorphic rocks. Marble. Marble is a metamorphosed limestone and dolomite. Its color is variable. The color are due to the various impurities. The principal use of marble is building and for ornamental and decorative purpose. Slate. It is a metamorphic rock produced by the metamorphism of shale. The color of slate varies from red, iron tinted red through various shades of gray and green. The slate can be used in electrical industries as switchboards. Phyllites. Phyllites are also the metamorphic rocks that are similar to slates but of slightly coarser texture. Phyllites have shiny luster due to the presence of large amount of fine flakes of mica. Schist. Schist are the foliated metamorphic rocks that are of medium to coarse texture. They are the product of the same processes of rocks that produce slates and phyllites. The color of schist vary according to the minerals present in them. They are generally weak rocks. Identification of different types of rocks. Sedimentary rocks. It has obvious stratification. Very soft, can be easily scratched by a knife. Obviously made of particles cemented together, contains fossils. Igneous volcanic rocks contains numerous bubble-like cavities that may or may not be lined with minerals. It is fine-grained, uniform in texture. It has bubbly or fuzzy texture. Glassy or highly vesicular rocks are always almost igneous. Igneous volcanic rocks. Igneous plutonic rocks. Now it is made of discrete mineral grains locked together, can be easily loosened by wedging. It contains large crystals in a fine grained mass. rock mass obviously cut across the other rock structures. Metamorphic rocks, it has fine grain with an obvious directional grain or foliation. It has obvious bands, streaks or clumps of different minerals. It is mostly made from quartz or calcite but is coarse grained and lacks sedimentary features. Now let's talk about mountains. There is no any universally accepted definition of mountain, but according to Oxford English Dictionary, a mountain is a natural elevation formed by in the earth that is present in the earth's surface, rising more or less abruptly from the surrounding level and attaining an altitude which relatively to the adjacent elevation is impressive or notable. Mountain formation, the geological process related with the formation of mountain is called mountain formation. Folding, faulting, volcanic activity, igneous intrusion, metamorphism, all are the causes of mountain formation. Types of mountains, there are 5 basic types of mountains. They are fold mountains, fault block mountains, dome mountains, volcanic mountains, plateau mountains, etc. In this video I will tell about fold mountains and fault block mountains. As we all know that the earth's mantle is made, our lithosphere is made up of tectonic plates. They are moving. When these plates collide and remain one over another, the crustal materials are pushed apart, forming the fold mountains. The process of thrusting and folding is called orogenesis. The scientific study of mountain is called orology. When two plates collide and undergo subduction, either symmetrical or asymmetrical folds are formed. In this process, the upward force are called anticlines and the downward force are called synclines. The Himalayan mountains in Asia, Alps in Europe, and in South America, etc. are the common examples of fold mountains. Among them, the Himalayan mountains lie between Tibet and Nepal. In this chain of mountain was formed as a result of collision and subduction between two tectonic plates. They are Indian and Eurasian plates 25 million years ago. The tallest mountain in the world, Mount Everest, was also formed by this method. Fault block mountain. A fault is a layer where rock can move passing each other. When rocks of one side of a fault rise relatively above the other, the block mountains are formed. When faults are formed, some materials appear above while the others go down. This process is called rifting. The uplifted block is called a block mountain or horse, whereas the drop block is called graben. Syria and Nevada range, horse mountains in Germany, Satpura horse in India, etc. are some of the common examples of fault block mountains. Now let's talk about geochronology. Geochronology is a field of scientific investigation concerned with dating and determining the numerical ages and dates for the Earth's materials and events. A geological map is simply the summary of investigation. It is done by collecting and processing hundreds of rock samples. It includes evaluation and interpretation of data through a variety of analytical techniques. In geology, the process of determining a chronology or a calendar of events in the history of Earth by using the evidence of organic evolution in the sedimentary rocks is called dating. Some of the common dating methods are relative dating method, absolute and numeric dating method. Relative dating method is a comparison of time period between two events. Relative age is the age of fossil organism, geologic event or rock that is defined related to the other organisms, rocks or events rather than in terms of years. Paleontological and biostratigraphic correlation method are the common relative dating method used by geologists. Other modern correlation techniques are geomorphological methods, sedimentary characteristics and other geochemical and radiometric methods. Relative dating is used to arrange the geological events and the rocks they leave behind is in a sequence. The method of reading the order is called stratigraphy. Layers of rocks are called strata. Fossils and relative dating. Fossils are important for working out the relative ages of sedimentary rocks. Geologists have studied the order in which fossils appear and disappear through time. This study is called biostratigraphy. Fossils can help to match rocks of same ages even if when we find these rocks a long way apart. This matching process is called correlation. It has been an important process for constructing the geological time scales. Now let's talk about absolute or numeric dating method. It is the method of finding the absolute age of a rock or a fossil. Absolute dates must be checked with the dates of other relative method of dating to make it valid. The most accepted method of absolute dating is radioactive decay dating method. Radioactive isotopes with known half-life are used to get the absolute age of a rock or a fossil. A number of radioactive isotopes are used for this purpose. Depending upon the rate of decay of these isotopes, different geological periods are estimated. More slowly decaying isotopes are useful for longer period of time, but there is less accuracy in absolute years. With the exception of radiocarbon method, most of these methods are actually based on measuring an increase in the abundance of radiogenic isotope. So it is the decay product of the radioactive parent isotope. Two or more radiometric methods can be used to achieve a proper result. Most of these radiometric methods are suitable for geological time only, but Radiocarbon and argon-40 or argon-39 dating methods can be extended into the time of early human life or into the recorded history. Some of these common techniques are radiocarbon dating use carbon-14 isotope, uranium lead dating use lead-206 and lead-207 isotopes, uranium thorium dating used to date fossil bones, potassium argon dating, argon dating, etc. Thank you.